Welcome to Module 9 of the Minimal Impact Design Standards, or MIDS calculator. In this module, we're going to talk about the sand filter and the iron enhanced sand filter best management practices. To see the other modules as part of this series, you can go to these links on the right side of the screen here, and that will show you the other modules that were being developed as part of this series. In this module, we'll talk about the guidance and resources that are in the Minnesota Stormwater Manual. We'll actually go to those through the MIDS calculator. We'll go into the calculator and talk about the sand filter and the iron enhanced sand filter, and then do a quick summary recap of the guidance and resources that are in the manual. So I'll escape here and we'll go into the calculator. This icon here, you remember, is for the MIDS calculator. You double click on that to open the calculator. And I'm going to create a new file called sand filter example. I'll save that, and my main screen in the calculator should open up. This is the Site Information tab in the calculator. There are three fields that I need to populate. The first one is answering this question: are you using the calculator to determine compliance with the construction stormwater general permit? I'll say no. I need to enter a zip code so that I can get my rainfall data. I'm going to enter 55155, and you'll see that my rainfall populates associated with that. And I need to input an impervious acreage. I'm going to input 2 acres of impervious surface, and I'm going to have 2 acres of managed turf on sea soils. I'm going to leave my defaults for volume in here at 1.1 inches, and my phosphorus and TSS, event mean concentrations, I'll leave those as defaults also. These can be changed. For example, if you need to comply with the construction stormwater permit, you'll change the volume requirement to 1 inch, even though the sand filter is a non-volume best management practice. It does not reduce volume. I'll click on the schematic tab, and you'll see all the BMPs that are in the calculator. I'll go down to the sand filter best management practice, click and drag it onto my screen, and it should show up. Excuse me. You can double click on this to open it up, or right click, and you see the edit BMP properties. When you right click, you enter that in the screen for the sand filter. Now we're in the BMP properties for the sand filter window here. You'll see initially this warning here off to the side. It says the calculator does not require sizing inputs for non-volume reducing BMPs. The sand filter is a non-volume reducing BMPs. Design criteria is in the Minnesota Stormwater Manual. To get to the Minnesota Stormwater Manual, you can click on the Help button or the various links that you'll see in the calculator. For now, I'm going to input my acreages: 2 acres of managed turf on sea soil and 2 acres of impervious cover. I'm going to route those to my sand filter. I'll click on the BMP Parameters tab, and you'll see that it is a very simple screen. Because it is a non-volume reducing BMP, there are no input requirements for it other than this question about, are you adding amendments to attenuate phosphorus? For now, I'm going to say no. So this is just a straight sand filter, no amendments. And go to the BMP summary, and you'll see the results here. For volume, towards my performance goal and my annual volume reduction, I'm going to get 0%. Does not reduce volume, as I had mentioned. It is an effective BMP, however, for removing pollutants. It'll remove 85% of your total suspended solids on an average annual basis, and it'll remove 85% of your particulate phosphorus on an average annual basis. Total phosphorus reduction is only 47%, however. We're not getting any removal of dissolved phosphorus. The calculator assumes that 55% of your total phosphorus is in particulate form, so 55% times 85% gives you the 47% removal. Well, let's say I had a performance goal of trying to remove 60% total phosphorus. This BMP is not getting me there. I can add another BMP, or I can amend this BMP. So I'll go back into the BMP parameters tab, and I'll change this question, the answer to this question about whether I'm adding amendments, to yes. So now I'm going to have an iron enhanced sand filter. When I do that, and we go back to the BMP summary, we'll see that I'm getting a 40% credit towards dissolved phosphorus removal, which bumps up my total phosphorus reduction to 65%. So now if I had that 60% total phosphorus reduction goal, I am achieving that goal with this particular BMP. As I mentioned, you can click on the help buttons or the links in the calculator to go to the manual. I'll click on the help button here. It'll take me to this page in the manual called Requirements, Recommendations, and Information for Using Sand Filter as a BMP in the MIDS calculator. We need to update this page to include the iron enhanced information, and hopefully that'll be done fairly soon. If I hover over page contents, you'll see that this page provides information on the methodology being used for pollutant reduction, talks about routing, provides some information on assumptions, and then it gives an example. We're going to add an example for the iron enhanced feature here in the near future. And then there's some links and some other information in the manual. I'll go back to the calculator. I'll close out this best management practice. And if I wanted to see results for my site, I would click on the results button here. Since I only have one BMP, all the results are going to be for that sand filter. But it provides you with a little bit more information than the screen that was in the sand filter part of the calculator. So it's a very simple BMP. Both the sand filter and the iron enhanced sand filter are associated with the one best management practice that's in the calculator. As I mentioned, to see other modules, you can go to this link, and that ends Module 9, Sand Filter and Iron Enhanced Sand Filter.